Hey, so this is me putting together the bit of the lecture that I obviously forgot to record right in the beginning. So here it is. These are some example models I made for showing you how baking works and what baking is. And what I'm gonna show you here is what they are and how I went through the baking process for them. And just so you can see how baking works and the process actually happening. I'm gonna show you a piece of software that you don't have to learn and that we're not gonna use, but just as an example to you what baking is and where it started and what it's supposed to do. So here I have something that's representing your low poly and your high poly. So obviously you'd never model something like this, but this is just to show you an example of how different details get read. And what the baking process actually is your low poly model, let's say your low poly piece of furniture, reading all the information from your high resolution version of that furniture or of that object and putting all that information into different texture images, different images that you can then use for texturing or inside a game engine, and essentially just shows you different things about the surface. And those images are going to correspond to the UVs. That's how they get made. That's why your low poly has to have UVs, so that when you're baking, the information you're taking from your high resolution mesh has somewhere to go, or at least some sort of guide to follow when it's creating these images. So let me show you some of the images that are essentially we're going to create. So this is one. This is called a normal map. And a normal map is a map that shows you which direction the details are facing, so that when you go in a game engine and you put your low poly object in a game engine, all those high resolution details will actually still react to sunlight. They're still going to react to light, and they're going to look shadowy and dark. Here's a further ahead example, which we're going to get to when we get to. But essentially, I just want to show you from the get-go what normal maps do. So let's turn on our, you can see that this cube is completely solid. It's completely, there's completely flat faces. It either goes light or dark. Let's turn on our normal map. So this is still the exact same cube, right? It's the exact same cube, but you can see as I turn the light, all kinds of different lighting information changes. And this is all done through this texture. Now let me bring up the texture that I was just showing to you, this one. It's still completely flat. It's the same low resolution cube. But this normal map, this purple map that I showed you, I put it into the normal slot, the normal detail slot, into any renderer, either Maya or this is Sketchfab that I'm using, Unity or Unreal Engine, all of those game engines. You put that in, and now it has something to simulate lighting detail, even though there's nothing really there. That's the purpose of a normal map, for example. And we have a bunch of other maps that we can use, and I'm not going to go over them one by one. I think in the actual lecture, I tried to go over them one by one, so feel free to kind of gloss over that part if you wish. But essentially, baking creates these different kinds of maps which have different effects on your model when you put it in a game engine. Now, the main ones that we worry about when baking are a normal map and an ambient occlusion map, which if I load up here, is essentially shadows. Now, I don't think this particular one with the example that I was showing you has a good one. So let me switch over to one that does, which was, I believe, this one. Ah, there we go. Actually, was the other one okay, actually? Yeah, the other one was okay as well. So an ambient occlusion map is essentially simulating, it's not simulating light anymore. Like you'll notice if I turn my lights around the model, they're still acting the same way as before. There's no 3D information that's telling you this is how things are gonna, how light's gonna curve around your object. But what it does have is shadows. And those shadows are always gonna stay there. And ambient occlusion, the word ambient occlusion, means occlusion, which means shadowing, that happens ambiently, which means happens around in the space. So if you put your hands really, 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 really close together and look at them, you're gonna notice that they start to kind of shadow each other. Like they're so close together that they start putting a shadow on each other. And if you're familiar with any kind of drawing or painting, you might have also run into this term ambient occlusion. And this is essentially the shadows that get created when things are very close together. And this map is something that, combined with your normal map, creates an interesting amount of detail and creates a very 3D effect in an object that isn't actually 3D, or at least it doesn't have a lot of detail in those areas. And this is generally what baking does. Before moving on to showing you how baking worked in the old days, not that old, people still use this everywhere, but still different to what you guys are going to do. Before showing you that, I want to just show you one more example of something you can do. So let's open up these planks here. So what we have here is a low poly cube, the same one, and what the high poly is these planks, right? So usually you wouldn't use a cube and then just put these planks on the cube, but for the sake of example, I wanted to show you what happens. So I took these planks and actually I put them in ZBrush as well, and I sculpted on them a whole bunch, and they look absolutely ridiculous. I'm aware. This isn't like, it was just to show different details. They look a little bit like chocolate bars and and stuff, but that's okay. The point was to show you the detail. So what I did was I then exported this, like I made sure it's in the exact same position as my low poly, because that's an important part of baking, because the low poly is essentially reading for details. So I take this and export my low poly and export the high poly from ZBrush, and the result that it gave me, if I go back to Sketchfab, is, as you saw a little bit earlier, something like this, right? And you saw this before, and you can see how even those details that were really far away got covered, and you know it's captured the details, and that's what we want. We want our baking process to capture all these details. And I'll just throw in the ambient occlusion as well, just so you can see it, right? I'm not going to go over what any of the other kinds of maps do, because we're going to do that in our texturing sessions. And again, I try to do this later on in the proper lecture, but you know, feel free to gloss over that part. It's not necessary. Listen to it if you wish, but it's not necessary at this point. We'll cover it more clearly and better in the future. But these two maps are the main ones that we usually worry about. Now we're going to be working in Substance Painter, and it's going to do a lot of the baking for us. But that doesn't mean we don't need to know how baking works and what it is, because essentially, even if I do have access to Substance Painter, sometimes I need to fix stuff, sometimes I need to make stuff on my own, and after you finish in Substance Painter, guess what? You're exporting texture maps again. And it's not just normals and ambient occlusion, it's a bunch of stuff, and we're going to have to know how those work too. But for now, just to be aware that the baking process just takes your low poly and reads a bunch of information about your high poly and puts all that information into the UVs. And the UVs, if I manage texture, you can see they're all following the same suit, they're all placed in the same places. They get put on the model. On top of this, you can add color, and I think I made a really terrible quick example texture just to show you how color goes on top of, you know, all of this normal detail that we created and all of this stuff. So, you know, all of that stuff is more texturing related, we're not going to cover. One last thing to go into before I show you X normals, and again, you're not going to use X normals, but I recommend seeing how it works just so you get the idea, right? You don't need to learn it, but just take a look. But before we get to that, I want to show you one more thing that this kind of that baking can use essentially, and this is something you might use in the future regardless of Substance Painter or otherwise, and this is called a cage. So a cage essentially is a copy of your low poly model that has been expanded to the maximum distance that you want your model to read for details. So a cage is telling your low poly model, okay, when you're baking, I want you to start from where you are now and go as far as I am, and then stop. And this is useful in different situations. It's useful when your low poly is really far away from your high poly. So for example, like here, my low poly is inside my high poly, and I don't think if I did it without a cage, it would actually read all of these details. If I did it without a cage, it would probably kind of check like this much and then be done. So what I did was I made a cage telling it it's gonna have to go this far. Like it's gonna go as far as it can until it hits the cage, and then it's gonna go back, right? So that's what a cage does. And you can add a cage to your baking process in Substance Painter, which of course we're not gonna do that now until we go to texturing, or in this manual process that you're about to see. It's not vital knowledge that I had to tell you about, but it is something that is important when you get to more advanced baking, and it might as well tell you now. Okay, so let's get started. Let's just do some baking so you can see how maps are created, and then it will segue naturally into the actual lecture when I was reminded to start recording. So here we go. Let's open up our program that we're going to use, and let's delete these example textures that left over from the lecture that we just had, and get rid of all of these. Okay, so let's open up X normals. It's really late. Okay, and go to our high resolution. Let me remove all this stuff before I explain. So X normals is an old program. It started, well, I don't know how old exactly. It started a while ago, but it's still getting updated, and it's still very good quality. And essentially what it is, it's just a program in which you put your highs and your low polys, and it bakes them, and it gives you images. So it's just a baker. It's a baker. That's a funny thing to say. So the way we use it is we start off with our high definition meshes, and then you put that in there. So I'm going to do the planks, I think. And we put our high resolution mesh in here in the high resolution section. So these are planks high. And these are all the objects that I exported from Maya earlier. And then we go to low definition meshes, and I'm going to put in the planks low. And do I have a cage for the planks? Yes, I do. Okay, so then on the low poly planks, I need to click use cage. Then I'm going to click, so right click, browse external cage file, week 5 lecture, and we want planks cage. And that's just telling me make sure your cage and your low poly are the exact same, apart from the fact that one is bigger. That's fine, but the topology is the exact same. There's no added or removed details. Nothing's been added or deleted. Then we go to our baking options, then we set the name, we set the size of the texture, we leave it at 1024 for now, and we click the textures that we want to bake. Actually, I'll leave it for 512, just so it does it a little quicker, and that means that I can essentially bake a bunch of other maps to show you what they do, but I don't really need any. So actually no, I'll just leave it, and I'll leave it at 1024. And then what we need to do is this ray distance calculation with this old school program. So you don't need to do this on the new programs, but in this old school program, you essentially have to tell the software to start calculating the difference before you even start baking. So right now what it's doing is it's saying, okay, point A to point B, the low resolution to the high resolution, how far is it? How far am I going to have to calculate? And you turn this on and you click go, and then you leave it for like, I usually leave it for a minute. I'm not going to leave it for a minute this time. I'll leave it for 25 seconds. And when you are done, let's just wait for that 25. Great. You click stop, and if you don't click stop, it's going to go on for infinity. Now you can close it, and now it's going to bake. And let me just make sure it's going to do it on the desktop. Yes, it is. Let's just click bake, or generate, rather. And what you'll see is it's going to start calculating, and it's going to start building up these maps one by one. So first it did our normal map, and you saw how quickly it did it. Ambient occlusion is more of a complex calculation, so it's taking a little bit longer. And you can see it's following the UVs of our low poly, It's using the details from a high poly, and it's just creating an image of information that we can then use. Now, this image is no different from any other image type, like JPEGs and PNGs and all those others. We use targas for video game stuff and film stuff. Targas have no compression, so they won't get fuzzy or anything. And also they allow you to mess around with them in interesting ways, which I don't need to cover at the moment. And here they are. Here they are. Let's open up Photoshop and just drag them in. So here's our normal map. What is this? Okay. All right. So here's our normal map. Looks as you would expect. So these are all the details from the planks that I showed you in ZBrush. The high poly of the planks was the one I showed you from ZBrush, and the low poly was just that cube. So it's taken those planks essentially and thrown them into the UV space of the cube. And let's show you the inclusion as well. Let's put it up here. Right, and here's the inclusion as well. It's showing you the in-between shadows. And let's go on Maya just so I can give you a look at something interesting. So here's a low poly cube. Let's give it a new material. Don't worry about how materials work. And this is going into something that the lecture does already, but I wanted to cover it a bit more clearly. I'm going to put the normal map in. So bump mapping is how you put in normal maps in Maya. Maya has terrible shaders. You're not going to use these ever. You might use them in the future, but you don't need to use them now, and I don't want to cover them, so don't worry about what I'm doing right now. Essentially, I'm telling Maya, use the normal map for this object. And let me turn on texturing, and you can see that the textures we just baked work on our low poly model. It's like, okay, well, why do they work on our low poly model? Well, let's open up our UVs, and you can see that, or you might not be able to see that, essentially the UVs are in this space, right, that we showed. That's where the image is. And if I select any of these UVs and move them around, so let's say, yeah, these are fine. Let's select these ones that correspond to the front here. If I move these around, you can see that the image moves as well. All right, so let's put our normal map just as an example. Let's get rid of our bump mapping, and let's put our normal map into our color, just so we can see what's happening a little better. So this is our normal map, of course, on our model, as I said before. Let's grab some of these UVs. So let's grab this face here, right? So this face on the UVs corresponds to this face on the model, and our textures fit in that area perfectly. Now let's move this UV up a little. Okay, so obviously we're distorting everything here. Let's move the whole, let's move the whole thing. Okay, what's happening? Why can we not, why is it disappeared? We have transparency turned on. Let's turn that off as well. So what's happening? Why is it like moving out of the space? It's moving out of the space because essentially your UVs, this is the whole purpose of your UVs. They read the image. They essentially say, okay, I'm gonna take information for color, and the UVs take that information from the image space, the UV space. That's where the textures go. And whatever your UVs are over, that's what they're gonna show on your model. And that's all UVs are. If I make this super huge, I can fit the entire texture on one face, as you can see. And the smaller I get it, the better it fits inside it, right? So essentially, this is why you don't mess with your UVs after you do your baking, because they're done specifically to, the bake is done specifically to your UVs. So this is the purpose of UVs, to take information, to take color information, to take normal map information, and anything else that you're using in a game engine to say how your 3D model looks. And I think that's everything I need to cover for how baking works, until I hand over to my past self, which is going to go through the entire lecture. So feel free to go through that, and there might be some information which I've missed, which I have already gone over in the lecture, which you'll see. Weird time difference, but yeah. I repeat myself explaining everything what it is and how it works quite a lot. So I'm not going to do that right now. I'll just let you go into the lecture. Have a nice lecture. Thank you. Bye-bye. Okay, so we baked our maps and they're right here. And let's open up Photoshop and take a look at what they look like, right? So let's open up on the desktop. We have our two targets. So I'm just going to drag both of them up here. Okay, so this is one of our maps, the ambient occlusion, and this is our normal map. Okay, so essentially, and you might notice if I open up Maya here, that it's put the details, the images that it's created into this UV space. So if I open up Photoshop, you can see it's in this UV space. It's representative of this. And if I go here and I just select this front face, you can see the front face is here where this area is. And in the texture, it's done that. So it's put detail on a picture representing the UVs, right? So the UVs are gonna pick up this information. Now let's just go back into Maya just for a second. Let's hide our high poly. Let's hide our channel box so we can see a bit better. And grab our object. And I'm gonna go into its material. Don't worry about the material for the moment. And I'm gonna go in here into, actually let's just go color. Let's go color. I'm gonna go into color and put a file in here, and I'll put in one of our textures that we just made. So I'm gonna put in the normal map. This isn't how you're supposed to use the normal map, but this is just so you can see what I'm doing, see what it means. So you can see that it's created this image that corresponds to our object, which I think you understand by now. And you can see here that it corresponds perfectly to where the UVs are, right? So this is baking. This is literally what baking is. You have a high poly and you have a low poly. The low poly is going to go in your game. It's not crazy resolution. It has UVs. It's clean. It's going to go in your game. The high poly has the detail. You take the detail and you bake it into, like you solidify it. You make it hard like a cookie. I think that's why it's called baking. And you put it into your low poly, into its UVs, essentially. You create an image that goes into the low poly. And I can apply any of these images that we just made. I'll put this to the side here. I can apply any of these images that we just made. So I'll put on the ambient occlusion, and I'll explain to you what those means later on. And the ambient occlusion does the same thing. It goes here. So why do we do this? Why do we do this baking? So if you go into Substance Painter, it's gonna do it automatically. You put in your low and your high poly and it bakes it for you, and it has all the maps ready, and then you can carry on texturing, right? But before Substance Painter, you did it by hand. I still do it by hand for certain techniques, for certain stylized techniques. But okay, so why do we need these maps? What's the point of creating these images? They don't look like color. They don't look like the thing we're gonna use to make it look pretty. So what's the point? So essentially, if I open up Xnormals for a moment again, there's a bunch of different maps here in baking options. So you have normal map, you have ambient occlusion, you also have a bunch of others. And we don't really need any of these others. These are the only two we really need at the moment. But all of these different maps are just information. They just tell the object different information. And if you select your object and you go into your attribute editor, which is this middle one here, and you go down all the way to the end, you have your materials. If you have a bunch of stuff here, you're not going to see it. You're just going to have a little arrow. You just need to right click your little arrow and it's going to pop down with a big list. And you can select it. So if you go down to your Lambert, your material, you'll notice that it has a bunch of things here. So let me get rid of these images for a moment and let me hide my UVs so you can see what I'm doing. So in your material, the thing that shows what your object is going to look like, there's a bunch of different things. There's color, and you can click the color and you can change the color. You can do all this stuff. There's transparency as well. You can change how transparent it is. There's ambient color, there's bump mapping, there's diffuses, all sorts of stuff, right? And essentially, right now, these are just sliders. They're just like very basic information, really color information. There's nothing specific, and it changes the entire model. But if you wanted to essentially be more specific, you need a map. And the map is, as you saw, gonna go over the UVs. Now, let's look at bump mapping, for example. So bump mapping is how far something goes up or down, and by default you don't see anything. Because if you make it go up and down, it's all the same, it doesn't matter, right? And this is, in Maya, this is like an old function. It should be called normal mapping by now. But essentially when you put in your normal map in here, it's going to simulate those high resolution details on your low poly mesh. And this is one of the main reasons you do baking, right? So I've input this information that I've created with the maps on top of the UVs, and I've put it into essentially what this is, the material, the surface information, the thing that's deciding how far things stick in or out for light, right? And I can do this for all of these other ones as well. Ambient occlusion, for example, is how you see shadows on your model. So if I get rid of this bump mapping for a second, and I'll just put in the ambient color. Now, Maya has a terrible renderer, so this isn't going to look pretty at all. But let's see if this works, right? So now, this ambient color, the before, was just black and white, right? It's just like, oh, everything's bright, everything's shadow, right? If we put in specific information based on the high resolution model that we had, it's now giving you very specific values in very specific areas. It's specifically saying, you know, this part's going to be shadow, this part's going to be light, right? And this is all based on this high poly. So that's the purpose of this baking process. We're creating information maps. We're creating maps that we put into the system on a technical level, and the system reads it and does different stuff. Now there's all sorts of different maps, and I'm going to go through a few of them later on. There's ones for how shiny something is. There's ones for how brightly something is glowing. There's ones for shadow, like you see with this ambient occlusion. Yeah, there's one for normals, which is, you know, how much surface detail there is. There's a lot of different ones, and we're gonna learn them. I'm not gonna go through them right now. I'm gonna show you a few as we go. In the video that I'm gonna upload at the end, I'll have some breakdowns that you can see there. But essentially that's it. Okay, so enough about explaining what it is. Let me just show you a few of these other examples of models here. So one thing here is, oh, I need to get rid of this terrible material. Hold on, because I've set it to the default material, so everything is gonna use it. There we go, and let's get rid of this. Great. Yellow, get out of here. Okay, whatever. So another example that I wanted to show you was same. I used this as a low poly as well, just for an example, and I made this, which is very basic, but it's essentially planks, right? It's a box. So I wanted to show you how this is gonna bake, and I also wanted to show you how another function of baking, which is essentially a cage. And what a cage is you take your low poly, right, the one that's has the UVs, and you duplicate it, and you essentially expand it out so that it engulfs your entire high poly. And this is something you use during the baking process. In the baking process, I would go to my low definition mesh and I would say use cage, and I would choose the file and then do the exact same thing. And the only difference is, before when I was baking, my low poly, which I'll give a different material so you can see it better, my low poly was here, right? And this is my high poly. And what the baking process does is it takes your low poly and it makes it do this. Like it expands it, it contracts it to see how much detail it can read. And sometimes it does it really well, and sometimes it doesn't do it very well. So sometimes you're gonna get all the details that you want inside your textures, inside your normal maps and all that stuff I showed you. And sometimes you're gonna get like a little bit and it's not gonna be very good. So what a cage does is it's a duplicate of your low poly, and it essentially tells your low poly, okay, I want you to go as far as this cage and then stop. So you can define how far you're going to read for details, so you can get all the details you need. So this is something I'm going to show you the result of. And another thing I want to show you the result of is this. Essentially, the result of these sharp edges, right? A lot of us have this furniture that has this really sharp edge, and what happens if you try and essentially bake this round edge with a low poly that's a sharp object and a low poly that's a slightly rounded object? So those are two things I want to show you as well. So let's just get straight into them. I'll just show you in ZBrush as well that this one with the planks, I took these planks, and because, as I said, the high poly doesn't need UVs, it's just geometry, it's just detail, right? So I took these and I put them in ZBrush, and I threw a bunch of nonsense on them. Like, this is just completely random to show you an example. And I put a bunch of stuff, and if you zoom in, like, the topology is completely ruined. It's completely, like, you can't put this in a video game, but you can bake from it. This is what ZBrush was actually meant for. The first thing it was meant for. It can do a lot of things now, but the first thing it was meant for was just creating high resolution details that you can then bake from, right? So let me go into Sketchfab. And here this is a slightly better online renderer, way better than Maya. And I just wanted to show you the results in here so that you can see what's going on. Let me just click this for the separate model that I'm going to show you after. All right, so we have our low poly here, it has the same UVs and everything. So let's add some materials, right? So the first material I want to add is the normal map, so you can see that. So it's just added it straight away. So let me just take it off for a moment. So our normal map is going to go up or down. It's going to be the detail. Let me do the basic one first. So this is essentially the bake I did before. You can see it's a bit distorted. That's because it was way too much detail, but I just wanted to show you the effects of it. You're not supposed to do it like this. But essentially this is it. It's put the details where they're supposed to be, right? And this is what a normal map is. This is this big, weird purple map, right? You see what this is. So the normal map is essentially simulating on a 2D image where light is going to hit it. And you can see as I turn my light left to right, it's actually changing the shadows and the light. But it's flat. So this is what the image is doing. It's feeding information to the system and saying, simulate this. This is the light direction. And the way the map does this is, if I go into Photoshop, just to show you a bit more of how this stuff works, it essentially does it with red, green, and blue. So it's saying, okay, red is details pointing in this direction. Green is details pointing in this direction. Blue is details pointing in this direction, right? And when you put them all together, they just look like purple. But it's actually telling the system to check all of these and say, okay, if the light is pointing, you know, whichever direction, use this information to calculate your result. So that's the normal map, right? Kind of cool that it can do this. So you use this on characters, you use this on everything. Everything except certain stylized styles use normal maps in 3D games. Let me show you another one. I'll show you the planks. So this is the planks. Again, I did it exaggerated, I did too much. You're not supposed to do it like this. You're not even supposed to bake planks on a cube like this. Planks are not very high resolution. You can just make the planks. You don't need to use a cube and then bake them out. You can use the planks in the game. But the details from them that I sculpted in ZBrush, you can't, of course. And this is how that looks, right? You can see the details, you can see all this stuff. And that's still just the normal map, right? So you're already getting a lot of detail from your mesh just using one map, without doing any texturing, without doing any of that, without even controlling what's shiny and what's not. You still get a lot of details. And whilst I'm on this, I'll show you the ambient occlusion for these planks as well. So the ambient occlusion, which I haven't shown you in Photoshop yet, is essentially just telling you where things are shadowed. Not where things are bright, just where things are shadowed, where there's going to be a permanent shadow, right? So that's all the ambient occlusion does. That's the wrong window. Bam. So let's turn that on. And you can see that it's created these permanent shadows in between. I'll just turn it off and on, right? So that's another map that we can use. And I'll turn off the normal map for a sec just so you can see this is essentially what the ambient occlusion is doing. It's not giving you any surface detail. It's not giving you any lighting detail. See, the whole face is turning dark. But it's telling you there's going to be shadows here. So when I turn on my normal map, now you can see it's changing the light on each of this detail, each side of this virtual detail, but those shadows are still there, right? Let's go through a few more maps. I'll leave the other example about how sharp or beveled something is for a little later. We don't need to look at that now, but I'll show you a few more maps. I'll make some right now and show you. So let's do some color first. People keep asking about texturing. Again, I don't want to go into texturing right now. There's enough information happening today as it is. But I'll just show you something very quick. I'm going to grab the low poly and I'm going to grab its UVs actually. So I'm going to go here, select the UV shell, and go to image, UV snapshot, and just throw, let me do that a little slower, image, and then you have a UV snapshot, this little camera. And whatever you've selected is going to be exported. So I want this to be 1024 size. That's fine. And I'll just, let's do a PNG. And I'll put it on the desktop, right? And call it gibberish. Apply and close, right? And let's just put that into our Photoshop, right? So I'm gonna go here, I'm gonna take that UV, and now it's showing me the UVs for my model, and you can see how now you can tell it matches, right? So let me put in a black surface, and let me just do some nonsense here. Wonderful. I am art. Okay, get rid of our guides and export this as a, let's do Targa again, it doesn't really matter. And just call this color blah. Wonderful. Okay, let's go back to our renderer. So when we're in Unity, we're going to be still using all these maps for your furniture, for your character, for everything, but this is a nice thing to show an example with. So I'm going to go on my base color and I'm going to choose a texture. So I can just pick a color like you saw in Maya. You can just pick a default value that's going to change everything. Or I can go to texture and I can import a new texture. Go to desktop and they pick our color. And you can see that our color information. But it's doing the color informations on top of the normal detail, right? So if you texture this more carefully and more properly, so for example, like this is going to be very shoddy, but let me put the planks below it. So the blank ambient occlusion, that's in week 5 lecture, baking. Right, and I'm going to turn this down a lot, quite a lot. And then I'm going to grab like a brown-ish, maybe not that much actually. Let me just throw in some kind of gradient map. And let's do something like this. Right, so this is not how you would texture, but I want you guys to see something a little more specific. Okay, and let's export this time, again as a targa. And let's hope that Sketchfab doesn't complain that I'm importing the same file. In fact, let me change the name. 2 A's, 3 A's, there we go. Let's import another texture. There we go. So now you can see, you know, it's still not a great texture, but you can see how we're starting to get different information, different detail, and how you can use this to create different effects, right? One more one more I want to show you. So let's just go for a few of these. You have metalness, which changes how metallic it is. You can change this with a black and white map. So if you have a black and white map that says this is metallic, this isn't. This isn't something you can bake. This is something you have to make. So the only thing that we baked is our ambient occlusion and our normal maps. The rest of the maps that you can make after that, and this is going a bit into texturing, so I'm not going to spend too much time here, are essentially just, you have to make them yourself. So let's just put that in. Right, so now you can see that the metalness is affecting only specific areas based on the map, right? And yeah, I'll stop there. I'll stop there. There's a lot of different other maps you can use. There's all the ones that are here essentially. You only need a few. The only ones you definitely need are a normal map and a base color. If you're making a stylized game like we're doing with Weather Cows, you don't even really need a normal map. You only need a base color. At least you still make a normal map and you use it in your texturing, but the only color you then put out and put in a game engine or in Sketchfab like I'm doing would be a base color. So it depends on what you're doing. It depends on the game engine, it depends on what's going on. Right, so that was the crashiest crash course you could get into what baking is. And a few of them might be very confused at this point, but essentially the only thing you need to remember for this moment is that your low poly and your high poly have a different purpose. Your low poly goes into game, like I've said a few times now, I'm trying to make sure people remember, and it has UVs. Your high poly is used for baking. That's the purpose of your high poly. You use it for baking. You use it to get these maps and then to texture. That's what you need it for. You don't need it for anything else. It doesn't go in the game. Like all those games you play, it doesn't have any high poly. Everything is a low poly and texture maps. That's all it is. And that's the main thing about baking, really. I think the only thing I want to do before moving on and seeing how confused people are, and again, this hard edge stuff cover later on, is I want to show you one of Holly's models, which you might have already seen. She might have shown it to you already. It's very cool, but I just wanted to show you some of its textures, essentially. So this is the final, has all the fancy stuff, all the post-processing and all that stuff. Now, if you go to just one of its texture maps, the color, just the color, that's base color, right? So this is what the base color looks like. She's doing a stylized thing, so base color is very important. A lot of her detail is actually just hand-painted. That's not even a normal map. If you turn the lighting, which I don't know if she has lighting on, oh, because I'm on base color. Right, so if you turn the lighting and you just had the base color, you wouldn't see this difference in light and stuff anyway. But this is her base color, it's all hand-painted, right? All of this stuff, the scales, everything is painted by hand. She has a roughness map. So this is a black, white, and gray map. And this is telling you how shiny stuff is and how rough it is, right? So everything that's white, because it's called roughness, is turned on. So white equals on, it equals 1, it equals rough, right? And black equals off, it equals 0, not rough, shiny. So white is rough, black is shiny. That's how the roughness map works. So if you took this map out of her final render, you see when I change the light here, you see how the glass is so shiny, and you see how the wood isn't that shiny. And this is kind of shiny, but not in the dark areas. So this is what the roughness map is doing. It's controlling this change. It's controlling how shiny and rough stuff are. This is almost completely white, so it's very, very rough. Not a lot of light comes off it. This is darker. And you can see this in your final render. Right? I think the only other ones that she has that are quite useful are ambient occlusion. You can see what her ambient occlusion looks like. So these are just little shadows that you can see that are always going to be there, right? And I think she has emission as well. So this is glow. So her water is naturally going to be glowy because she's put a color into this emission slot, into this glow slot, right? So the only maps that she probably baked are her normal map, which you can see here, because as I said, like this is flat, but it looks like it's got stuff, right? So her normal map she probably baked. The rest she probably painted by hand. Probably baked her AO map as well. And the rest you can do by hand. So it's a combination. But you can see how, again, it's the same process, low to high. She probably had a high resolution model as well for the baking. Right, okay, that's enough. That's too much. I'll stop there with the baking stuff. Let me go to Discord and see how people are doing. And let me make sure that I am still recording. Yes, I am. Wonderful. So let's go back to Discord. Let's see. Anyone have any question? Anyone completely lost? I won't go over everything again, so don't be afraid to say if you are lost. Just let me know in case, so I have a better idea of whether people were able to follow along or not. What's going on? Da, da, da. So it's almost cemented into the low poly. Yeah, yeah. I don't know why it's called baking. Baking is used in a lot of different tech stuff. It means information is solidified into another form. So the high resolution geometry is solidified into a texture where it can't be changed from the 3D anymore. I think that's what it means. I'm glad we're not using Maya to bake normal maps. Yeah, we're not going to use Maya. We're not going to use X normals. We're not going to use any of that stuff. We're going to use Substance Painter. It's going to be way, way easier. But easier to show you the fundamentals and the core theory of baking this way. Is it cheesy to say that baking my brain? Yes, it's cheesy. Would this be used to help games run better? Yeah, so essentially, it's not about making games run better. It's just a natural thing that's part of a game. So like your textures that you're gonna put on a model so you can see its surface detail, right? Its color and shine and everything. You need to make those somehow. So whether you make those by hand or you make those by in Photoshop or you make those from baking, or you do both and you first bake some maps and then use them to texture, which you do for stylized stuff or in Substance Painter. That's just the process you make it. You're still gonna need textures. If you don't have any textures, the entire game is gonna be gray, right? So it's not so much about making them run faster, it's just about having them. But yes, if you put in your high resolution model in a game, it would not run very fast. So that's why you can't do that. Your connection has been that bad. Don't worry, it's a good thing. Sarah reminded me to record. Yes, there will be a recorded version. I'm just gonna have to get around to using it. So the stuff we've made so far are the higher poly versions, so we need a low poly version too. Right, so that depends on on the person, because some people are modeling high resolution from the start. Other people are starting with a block out and then going slightly more resolution. Some people are in the middle. Most people have models that need some cleanup as well. So it depends on who you are. I'm gonna go through low to high, high to low, and optimization today. So we're gonna go through all the possibilities. Everyone should be covered. Look at this. Look at all these messages. What's up with you guys? Why? Like I tell them not to message during lectures, and today they're like, no, we must reach him. All right. Let me give you a break from my voice for like 2 seconds. And let me check to see what we have here, in case there's anything majorly missed. It's fine. Very good. It's water. It's not coffee. Okay. I think we're good. I think we're alright. I'm gonna close the brush because we don't need. And I'll leave this up for the moment. Okay. Alright, so we went for a bunch of baking stuff. You have an idea now of what the purpose of a low poly and a high poly is, I hope. And if not, this is the lecture. There will eventually, hopefully, be a a better video that gives you more specific stuff. Gives you more specific information. Okay, now what do we do with this? We can just go back to modeling. We're not texturing yet, we're not baking yet, we don't need to worry about it, we just need to know what it is. So let's go back to texturing. Let's go back to modeling. Let's go back to modeling. We're not texturing, we're not baking, let's go back to modeling, right? So a lot of you, pretty much all of you are still modeling. Even those of you who have big finished scenes with high resolution models, you still have some stuff to do because you don't have a low or high poly and you don't have a clean optimized mesh, most likely. So what I have here is a blockout scene with some errors in it, not a lot, but quite a lot actually, errors in it. And then this scene I took and turned into a high resolution scene. So you can see the most significant change. The most significant change was the toaster, of course, but other things as well. Softness and edges, specific details, things like this. And then this high resolution scene, I changed into a low resolution scene that's ready for UVing, right? And you might notice that there's not a big difference. So sometimes there isn't a big difference, sometimes there is. If I took this high resolution thing and did a bunch of ZBrush work on it, which isn't necessary, but if it was a model like that, let's say you're doing a suit of armor, there would be a big difference. But the main difference is that the low resolution has slightly less polys in things that we don't need, and has no errors whatsoever anywhere, and it can be UV'd, and you can use it for baking. That's the only difference. So what I want to do essentially is show you guys how I went from this blockout to this high res. And how I cleaned up some issues, right? So the first thing I want to do is like go through some of these issues that are very broken and show you why they're bad. And then I'm gonna go to this case, and I'm gonna show you how you can essentially take a very boring piece of square furniture and make it only slightly less boring, right? Just a little bit less boring, a little more softer, a little more high quality. And I also want to show you how to make a toaster, just because it's an interesting, weird shape, and it just looks very detailed, even though it's not a very complicated thing to make. I just need to make sure I remember how. And then I'm going to take you guys through taking that high poly and just making it a bit lower poly. So if I select all of these, it doesn't tell me. No, it does, yeah. If I select all of these, this is about 1023 tries, so not very much at all. This isn't a finished scene, of course, but still, not very much. If I take the high poly, it is 1600. So again, not a big difference, but this is only 3 assets, and they're not very detailed to begin with. If you had a whole room, and the difference is 150,000 and 260,000, right? Because for every asset you've been a bit more careful. That's a big difference. Now that's about 60,000 tries, not 200 or something, right? So it's a principle that carries over on larger scale. Okay, so let's just get started. And I'll just save to make sure I don't overwrite. So let's make this high poly. Let's make this weird case high poly. Right, so far, this basic piece of furniture is a blockout. All of this is a blockout. I think let's do the optimization first. Let's do the optimization before we go ahead and start modeling. Okay, so optimization. I saw someone with a desk like this. Some of you guys might know who it is. I don't know what's going on here. This is not how you should have a desk. So the problems with this is that you have n-gons here. So this is 1, 2, 3, 4, 5, 6, 7, right? 7 sides. You need 4. 1, 2, 3, 4. Also, there's no reason for these lines to be going here. So what you can do is you can literally just pull all these points to the same spot and you're good, right? If you think that's really ugly and you're like, oh, I don't like this, just put them to like a slightly different spot. But still, you really don't need all of these things to be like that. You don't need that. That thing was not doing anything there, and you can have something like this. And this is just it's got no end-ons. It's safe. You'll do the same on the underside, and this would be fine. So this is an error I saw. This floating point problem, where people have these floating pieces of like points that connect to this ridiculously big face. I see this pretty often. The other thing I see often is on cylinders or cylindrical objects. People have these edges like this. And at some point they've done something and they've deleted a bunch of the middle edges, and then they have something like this, where there's a bunch of empty space and nothing connecting this. This is just not a 3D object anymore. Something else that happens is if you double select an edge, to delete it, you have to hold Control. So if you press Control, delete, it's gone, right? And I've said this before, some people that might not have seen it. You hold Control, delete it. If you don't hold Control, it doesn't delete it. It just gets rid of the edges. The points are still there. And that's when you often see these floating points in people's models. So you don't want that stuff. You want things to be four-sided. You don't want floating points like this. Make sure you hold Control. So this is another thing. The other common thing is beveling. If you have a bevel and you do a bevel, you'll be left with n-gons, more than four-sided shapes. Because when you do a bevel, it doesn't reconnect anything. It just bevels. It just adds more resolution. And then it's left you with this. So you need to come back in here after you do a bevel. And you need to figure out how you're going to connect stuff up. You can go all the way across if you want. You can just do this. And like this is kind of okay. It looks really ugly, but it's still like 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4. Right, that's good. Best case is just something like this, and this is still fine. So like this is still fine. This weird shape because it's 1, 2, 3, 4. Right. So this is another thing I see very often. In your blockouts, not a big deal. When you start doing your high resolution modeling and your low resolution modeling, it's a big deal. You don't want to have that stuff. It's going to ruin your UVs. It's going to ruin your baking. Make sure you keep stuff in quads, 1, 2, 3, 4. The last thing I'll go over for optimization is what the hell topology means. So topology means essentially the surface, the surface net, the net in the surface, right? And the way topology works is with loops and with poly loops and edge loops, right? So an edge loop is a loop, is an edge that goes all the way around, right? That's an edge loop. If you double click any edge, it's gonna select the entire edge for as far as it can. If I kind of mess with this, the edge loop is gonna stop there because that's where it terminates. See, it follows along this path of squares, and if you break that path of squares into a triangle, it's gonna terminate. It's like, okay, it's ended. The loop has ended. And then, so this is one aspect of it. The other aspect is a poly loop, and that's a loop of polygons, of faces, right? And it goes this way. So if I select one face and double click the face next to it, it's gonna go all the way around for as far as this poly loop goes. Again, if you terminate it with a triangle, it's gonna stop, right? When you're modeling really complex objects, when you're modeling, you know, armor and all this complicated stuff, your topology is going to get really complicated. It's going to start looking very fancy, very, very convoluted. Things are going to start, you know, things are going to start sliding up, they're going to start sliding down, things are going to concave and stuff like this. It's going to give you some issues. It's okay to have a topology that's a bit weird. It's okay to have things end in triangles and stuff, but the cleaner you keep it, the more of these clean loops you keep, the easier it is going to be to model. And whilst I'm creating the high poly, you'll see this. Alright, so that was all the optimization stuff. I just wanted to get it out of the way in the beginning. before we get into the other stuff. So let's grab this and essentially start making it high poly. So first thing I want to do, these things are super blocky, super square, way too blocky. So all I'm gonna do is I'm gonna grab the surface edges and I'm going to bevel them a little bit, just because I want them to have a little bit of information here, a little bit of a bevel, so it doesn't look like a hard thing. Look at your desk if you have a desk in front of you. Look at the corner of it. It's probably not razor sharp. You probably can't cut yourself on it. It's probably a little bit rounded unless you live in a really dangerous house, right? So in 3D, when you're creating these razor sharp edges to your furniture, it feels very unrealistic. And that's why you essentially go back to these razor sharp edges and you just bevel them a bit. And you can do these for any areas where you think the detail will be noticeable. 3.2, 2. So I'm not gonna do it for like some of these bits on the top, and you can see in the high poly that I made before, you know, I did it here and then I left the rest because I thought it wasn't necessary. But these borders were important for me to round so that it looks more natural. So I'll go here and I'll round these borders as well. I'll get rid of this on the bottom because nobody's ever gonna see it. And then you can round these borders and do something like this. Little bit. You see it's giving you a bit issue here. That's because this connection has messed with it, essentially. So here I'm just going to straight away, I'm not going to leave it till later, I'm just going to clean it up. I just don't want that to be there. But how do we clean it up? Because we want to keep this detail. So let's grab this thing, just raise it, right? Something like this. Oh, that's so ugly. See, this is our issue because we have this weird topology with this, right? Our flow isn't very good. So let's undo that and fix our flow first. So let's get rid of these. And let's make this go around the top. And I'll turn my symmetry on as well, so it's a bit easier. Let's make this go around the top. Object X. Object Z. There we go. And let's make it go up here. Oh, it's giving me issues. Okay. First, let's make one go all the way around then. Connect. And do that. Alright, now let's do the other thing and fix our topology. So what I've done is, I've essentially given it more room to breathe. Now this can go all the way up, hopefully, and this can go all the way around, so it has better flow. This is what flow means. You can see I did them very shoddily, they're not great, so what I'm going to do is I'm going to grab them, and I'm going to move the pivot point, and we've done pivot points quite a lot, to the point that I want it to match with, and I'm just going to scale it sideways. It's going to match with it, and I can do this on these ones as well. I can just move their pivot point to the thing I want it to match with, like that. Actually, I want it to match with this, I think. Alright, so now we have this slightly easier topology to work with. I can grab this edge a bit more easily, and you can see our termination here makes it so that we can't double click and get that one, so we still have to like select this. We can do an easier bevel, no issues. If I did that to begin with, I wouldn't have had to play around with it just now. So if I fix my topology issues in the beginning, less work later on. These ones, just to keep our flow better for the high poly, I'm just going to do it like this. For our low poly, we can get rid of it. Already this is like slightly softer. You can barely tell, right? But it's small things like this across an entire scene that makes it look a bit better. Now, this isn't very efficient, this part here, because essentially this, I should have made this whole thing blank. So I'm going to delete this, and then I'm gonna merge it up because there's no reason for it to be here, and I'm just gonna delete this edge, and now we don't need that, and I can just grab this and move it back down, have something like that. Then these middle ones, I think I'm gonna just do a stylistic thing and just like move them back a bit, just so they look a bit more furniture-like, a bit more like there's a bit of interest there. And that's pretty much the body done. On the other one, you could tell I did do some fancy stuff up here. Like I separated this thing so that it looked more interesting near the top. I'm not going to do that right now, but you can see that this is a detail you can create as an example. And down here, I think I wanted to round off these areas to make them look a bit more realistic, a little less razor sharp, a little less dangerous. And you see here, I got a thing here, just from doing this bevel on this, doing the bevel this way, I have now like 1, 2, 3, 4 connections here, which is weird. You can quickly fix these, not worrying too much about topology by doing this. You can just like grab your target weld, and that new point that the bevel is created, you can just grab that and shove it to the end. Let me get rid of this nonsense. Get rid of symmetry, right? That's a bit better. And this thing here as well. Let's bevel this. It might seem like all I'm doing is beveling. That's what a lot of the stuff is when you're working with furniture, because the main thing that you can't do with furniture whilst you're making it is make it look less less CG, less artificial, right? When you're working on characters, that's a different thing. That's a different thing that you need to look out for in terms of detail and optimization and that sort of thing. Actually, this is dumb. Why did I do it like this? You can do it like this. Go all the way to the end. And I'm just going to be quick. Right? And I'll just do it on the top so you can see the idea, so I don't have you watching me work on a handle for a million hours. See, I'm doing the thing where I select the points and I use scaling to kind of flatten them out. Right. And now I'm just going to delete the other half temporarily. And now because I fixed my flow a little bit, although because I'm an idiot, I didn't realize that I could have just done this. This is easier. Why didn't I think of that? Let's see how this does. Give it a bevel. Yep, it did okay. Right? And you can do this for your handle when it looks a bit better. And that's it, right? We can get rid of the blocky books for a moment and this stuff. But essentially all I did was make it a bit softer. Make it look a bit less like a block. Give it a bit of this stuff, right? You can then go back in and get rid of all these sharp edges that are left over from before you did your bevel. It's going to fix those as well. And when you have a whole room of this stuff, it just feels a little bit better than the sharp stuff, right? A lot of the reason I went in depth on this bookcase for so long is because a lot of you have furniture like this. A lot of you have these blocky pieces of furniture, and those of you that aren't doing super high resolution models are just wondering, like, how can I make this look less like a block? This is literally it. Just bevel a bit more. Give it a bit more detail. You now know that your low poly is the thing that goes in the game and has UVs. Your high poly doesn't, right? So this thing, even if I gave it like way more extra detail, I'm not gonna UV this. I'm gonna UV something that's a bit simpler than this, slightly simpler than this. So it's not a big deal if I put in loads more information. It's not a big deal if I take this in ZBrush and then scoped Viking ornamental writing on the side, right? That's fine. It's the high poly. Now let's say we want to take this very simple thing that I've been putting too much attention on today, and I want to make it a low poly, right? So literally, all I would do is I would go in here and I would delete the middle bevels of all this stuff. And that's all I would do. Because it's not very high resolution to begin with. I would even argue you could keep the bevels in, because they're that low resolution. It's really not a big deal. It's a very low resolution asset. But depending on what your model is like and how much detail you have, maybe you want to like get rid of one or two things. For this object, I actually wouldn't mind, except for this handle, which is way too much. But for some of you, you have quite high resolution stuff. Might be a good idea to get rid of stuff you don't need for your low poly. Okay. And the other point of doing this just now is that if you look at them side to side, you don't see a difference. There's no difference between these two. If I brought back the original block out, you'd see a bit of a difference. And with the other high resolution that I did before, you definitely see a difference, because it had this extra bigger detail on the top, right? But generally there's no difference. But there's barely a difference in tries as well. Honestly, if you're making this level of detail in an asset, I'd say even keep it. You could keep this high poly for UVing, depending on what you're doing. You guys saw a very fancy sofa the other day in the video lecture that I recorded after classes, and you saw smooth mode and all that stuff. So, you know, if you're working to that level of high resolution, you definitely need this technique of lower resolution. But stuff like this, it's good to know that you can go even lower. But depending on the game you're doing, it might be fine. So imagine you're playing a Skyrim game or a Last of Us game or something like this. You're pretty close to the objects. You want to see those. You want to see a bit of detail, right? If you're playing an RTS, you're out here, and you don't see these details. So some of what drives how much resolution is in there is the game that you're making stuff for. Now we're doing stuff for practice, and for learning. So I would like people to be considerate themselves and think, okay, well, is my thing have too much resolution or not? Between these two that I just did, the difference is 10 tries. So this isn't worth it. Just keep the high poly. There's no point in going lower, right? This toaster, excuse me, the difference between this one and the other one I had was about 100. Again, not a big deal. The only thing about this one that was different though is that this one, the high-res toaster thing is a bit messier. Like you can see the topology is messier. This is gonna be harder to UV, a bit more of a pain in the butt. And some of the stuff you just really don't need. It's like, it's not even about resolution. It's just about necessity, right? I showed you how normal maps work. These grooves, this button indent, you can get those in the normal map, so you don't really need them in your low poly. They have other uses. So the low poly, I got rid of those. Like I still kept the line here because I want to be able to cut this off with my UVs, but essentially I got rid of these grooves that you see. I got rid of all this detail just because I knew I could put it in my normal map. It's not even about resolution, it's just I didn't need it there logically. And I tried to fix up this back slightly because it was just really crazy to begin with. It's still pretty crazy, but it's a bit better. That's what happens when you try to put 4 holes in a 3D object. It just gets a bit nuts. But again, this is like 300 tries. If I select everything, it's 500, and that's just because circular stuff takes a lot of resolution. This is fine. Pay attention to your poly count and your try count. If your single asset doesn't go above, 1,000, 2,000, whatever, as long as it doesn't go above those numbers, you should be fine. And even I would say you don't need to worry about the try count. The only thing you need to worry about whilst modeling in terms of your detail, how much detail or how little, how much detail to take out, is a few simple things. One is when I delete the thing, does it change the model? Yes, right. Probably don't want to delete it then, because it's changing the actual look of your model for the worse, right? If I go back to the high poly, and I'm like, okay, I want to make this lower poly, does deleting this initial groove in the middle change the model? Not really. It changes it a little, but I'm going to put that in the normal map anyway, so no, not really. It doesn't change the overall shape. Okay, does deleting this edge make the model look different? No. Does deleting this edge make the model look different? Like 0.1%, so no. Alright, well, I didn't need any of that, right? So that's one thing you, whilst modeling and you're creating your lows and your high polys, essentially for your high polys, go as far as you want. Put as much detail in as you want. For your low polys, take out everything that you can't see or don't need, and leave in everything that defines the overall shape and the look of the thing that you're trying to make. I think I need to stop there and see how people are doing, because it's in danger of turning into a segue, into a big tangent. After seeing if anyone wants to cover something specific, I would just go through and show you how to model a toaster, essentially, just because it's a weird shape and it might be, you might see a new way of modeling. And after that, 3 o'clock, after that we'll see how much time we have, and we might just jump into feedback sessions. And I think I want to show something for character modeling as well. How are people doing? But with that baking thing, won't our models look like PS1 graphics? No, it's like the baker looks old, but it can bake super high resolution. It doesn't make a difference. Is there any tool that shows the edges needed and the ones that are not? No, there isn't. You have to figure it out yourself, essentially. You have to be aware of the thing you're modeling. Be like, okay, what isn't necessary for me to, what's necessary for keeping the shape? And what's necessary for conveying the details that I want to convey. For your high poly, that's, you know, any detail that you want to come through whatsoever, even nuts and bolts, little grooves, engravings, everything. For your low poly, it's anything that's the main shape. You said we have to press Ctrl Delete when removing the lines, right? Yes. Toaster, will you be going over everything you've done in this lecture in the video? Just curious because my call is dropping. Yeah, so I'm recording the lecture, so everything is gonna be in that lecture. The reason I didn't want to record these lectures to begin with was because, as you can tell, they go for a lot of stuff really fast. The pacing is whatever I can manage, and they're just not very easy to rewatch, right? Like in the moment, I'm kind of going through stuff. I'm hoping you're kind of following along and figuring it out. But as you can tell, it's hard to fit in all this information in an easy to understand way, especially since my voice just keeps going nonstop, right? I want to make videos that are kind of really good quality tutorial that you can follow through really efficiently. So instead of it being a 3-hour lecture, it's 15 minutes. But those take a lot of time and planning. So that's why I'm recording the lecture and putting them up, because at this point, it's not possible to make those videos at the moment. They literally take more time than I have in a week. Everything else is taken up at the moment. So for now, these lectures are the best we got, the video recordings of them. But they should be all right. And as I always say, if anything is super unclear, you can tell me and we can make it a priority. Okay, anything else, or should I move on to the toaster? I don't think there's anything. Nobody's typing. All right. Let's move on to the toaster. This gosh darn toaster. So essentially, I took out the block out. Right. Let me just start from scratch. Let me just see if I can like start from scratch, and we'll see what happens. I didn't use the block out toaster. I just completely trashed the block out toaster and just start again. So first we want to get an object here and match the general shape. And the general shape of a toaster is thankfully quite simple. It's just a bit wide, really. That's pretty much it. And the most interesting thing about this toaster is that The most interesting thing about this asset, because it sounds less stupid when I say it that way, is the rounded top and the fact that it's got the front and the bottom segmented. So the first thing I'm going to do is just round the top and create something that's roughly about 1.5, 0.15, and give it like a few more segments. I think I'm going to separate it down the middle from the start, just for to make sure I get no issues later on, and separate it twice more, because I know that that's something I'm gonna need. The bottom I'm gonna delete, because I don't want it. And these I might push all the way down from the get-go, because there's no point in them. Just gonna straighten these out. Right. So straight away from the beginning, I'm gonna just fix these problems. Just there's no point in letting them sit. And as I showed you before, I'll do it lazy first, and then I'll do it better. Or maybe I should just put them across. Yeah, put them across would be easier. It seems like it's more resolution, but it's fine. I'll clean it up after. And I'll leave the back for now, for demonstration purposes. So we have our top bend. I would even say that's too little. If we assume that we're making our high poly first, I would even put in a bit more resolution here. And you can do another one on the top if you wanted. I'll just leave that for now. Let's grab our front. And if you get really annoyed by, oh, I have to click every one of these squares, then don't. Look at it from the front. Grab all this stuff. It's going to grab the front as well. And then deselect the back stuff, and you still have the front. It's a little better. And let's just push this out. Let's extrude it a little. Like this. And now we want to just round this whole thing, really. And let's see how far it's going to round, because sometimes it gives me trouble. Okay, so that's alright, that's alright, that's alright, that's alright. That's not too much, because you can see like the actual bevel is not very big. You can tell by the way the light bends, right? So it's not that strong of a bend. Is there? Oh, disconnected, right. So also you could I kind of want to add a segment. That's what I want. Bam, like that. And you could also kind of afterwards just grab the new bevels that it's created and just move them back a bit, because I want this to be a little bit rounder. But this one I kind of want to be here, so I'll leave that. And here it's giving me some weird stuff, so I don't want this stuff. Get out of here. And actually, I think I'm going to get rid of these things altogether, because I don't like how they're sitting. And I'll just add them. Let me do my, let me do symmetry. There's no point in. So is it world X? No. Is it world Z? Yes. Great, okay. So we don't have to do everything twice. Okay. Alright, so we're pretty much almost done. I'm going to soften this stuff, mesh display, soften edge. This front stuff, might as well soften as well. It's alright. Like, it looks a bit weird, doesn't it? It looks like there's a bit of an issue here. That might be something I need to focus on later and make sure I solve. But you see these sharp bits here? They're kind of sharp. That's because when you do a bevel, if the edge was sharp to begin with, it's going to stay sharp. So you need to soften it after that. Okay, so how do we get this interesting groove in here, right? Well, essentially I've extruded the front so I know where it starts. I can just insert an edge loop behind it. Then I can insert another one in the middle. And I can grab this middle one. And because I deleted my underside, and actually I'll delete this underside as well, because again, we don't need it. No one's ever going to see the underside of our toaster. Ever. If your art director ever asks you, why does your toaster have no bottom? You can be like, because nobody's going to see it. Ever. And that is a fair answer. That's how you decide what edges to delete. It's like, are you ever going to see them in the game? No. Get rid of them. So we put our little edge here, didn't we? Let's move our pivot to the bottom, and then we can just have my symmetry on. Let's take that off. Right, move pivot to the bottom, and then we can just kind of pull it in a bit, scale it in a little bit, so it gets pulled in, and you can barely see it, right? Well, let's use our harden edge. Select the edges in between it, mesh display, harden edge, and now you can kind of see the groove. Not from too far, of course. That's why I deleted it afterwards, because you can barely see it from far away. I might as well just bake it in, leave it for the high poly, get rid of it for the rest. I didn't put on these grooves either, because I thought you could do that in the texture in Substance Painter very easily. So we're almost done. These buttons as well, I didn't want to model. You can just put them in later. But this stuff, the big knobs, you can't, they stick out too much. You can't fake that. So let me squeeze this up a bit, make the bottom part. And also actually at this point, do this. I'll move it forwards a little bit because it's a bit forward facing. Like that. And you can see there's this weird kind of swoop. You might not even be able to see it, it's very faint. But I can see it, so I'm gonna fix it. Right. Now we have a slightly bendy toaster. Wonderful. Let's grab the bottom. Again, easier because we have no stuff. Extrude, pull down. Maybe a bit less. Right. You can see it's giving us a bunch of hard edges because it's a new extrusion. Let's soften all of those. See, I just double click the one next to it and it goes all around the poly loop. Soften edge. And this one's kept hard, but that's okay for the moment. Or is it because of this? It's because of this. These ones want to stay hard because they're quite sharp, these edges. If this was if I really worried about it, I'd probably soften the back as well. But at this point, I'm not worried. I'm not paying attention to that. And I'm just going to grab all of these and I'm going to scale them in a little bit. Something to show you guys here. I'm selecting an edge that's all on the same level, right? So if I scale it in by all axes, it's still going to remain on the same level. If I select two edges, my pivot point is now in between them. So if I scale it on all axes, it's also going to scale it on up, of course. So it's going to scale them upward, so they're going to get wider, right? Whereas if you select a single edge, the pivot point is right on the edge. So if you scale it up and down, nothing happens. So if you scale it by all axes, you can do that. Just something to keep in mind. If you want to scale multiple things outwards but not upwards, grab this middle one, because you have like your side ones and you have these middle ones. So these are using only these two axes, only these two, and this one uses only the up and down, the forward and sideways, right? So this way you can push it sideways and it's going to stay the same length, the same height. But if you use all of them, it's going to go up, right? Just something to keep in mind. Let's do this, and then let's do the same technique we did before. And just scale that in a little bit, and harden these edges. Mesh display, harden edge. Here it gets a bit weird, right? So I'm gonna grab all of these. No. Come on. And mesh display, soften edge, not that you can tell from that far. And this one, I want to, and notice I have world Z symmetry, so it's doing the same on this end. I don't have to worry about it. You use world because it's in the center of the world, so it always knows what's on either side. If it was over here, world symmetry wouldn't work because it's counting the world, not the object. Let's go back here and pull this out. It doesn't want to use my snapping for some reason. I'll just do it by hand. And actually this is hard as well. Let's soften these. No, come back. There we go. Now we have that bottom groove and our weird What's going on here? Ah, these ones want to be hard. So display, hard edge. Wonderful. Right, so we have pretty much the basic done. The only thing is left is these two buttons, these two knobs, and the top stuff, right? Okay, so let's do the knobby things first. I'll just throw in the cylinder, very basic. Put the pivot to the front, put it somewhere here, and it's about there-ish. It's about this big and a little thicker. Notice that I'm using all the tools I've already taught you. I'm not using anything fancy, I'm not using any other techniques. I'm just using all these tools. It's just about the way you use them and what you do with them and how you match what you're making. I'm going to select the middle. I don't want to select all of these faces. So I'm going to select the middle vertice. I'm going to hold Control and right click and it brings up a new menu. So usually we just have right click, which is vertice, object mode, edges, faces. If you hold Control as well, it's telling you which one to switch to. So if I go two faces and two faces, it's going to select all the faces around that point I had selected. So I don't have to select them all one by one. Click extrude, extrude inwards, extrude again, move it down, scale it down. Oh, shit. There we have it. I wonder if I have to edit out any swearing in the video lectures. I guess they're on my personal channel, so it's not it's not a major issue at the moment. Should be a bit more careful though. Right, and to copy it over, you can just modify freeze transformation, so it's all the same. Duplicate it and move its pivot point to the center of the world or to the middle of what you want to flip over. This word X, oops, word Z because we're facing the wrong way, I'm afraid. And typed in -1 Z and it flipped it over. As I've shown before, flipping over the scale changes the side. And I pretty much did the same thing for this button. Notice that I just used the default cylinder because it's pretty round already. For the low poly, I reduced it because it's from this far you can't tell whether it's high or low poly. In fact, I think it's here you can tell. So this is the high res, right? And the low res is significantly lower. It's very basic, just because cylinders take up lots and lots of information. And these ones, they looked too blocky when I reduced them, and they weren't that high anyway, so I left both in so you can see the difference. If it was a game that's first person and I was looking at this radio this close, I would keep the fancy one. I would probably still delete the middle thingy though, just because you don't need it. But I would keep the fancy one. If it was a game that you're looking at it from here, I would keep the low resolution one, because you can't tell. If it was a game that you're looking at it from over here, I wouldn't even have those buttons there. I would just paint them on. Honestly, there's no reason. Let's go back to our dude. Just looks like a well, I was gonna say it looks like a happy toaster. It looks like a sad toaster, to be fair. But yeah, that's the rest of it. It's just that. Whoops, where did we go? There we are. And bada bing, bada boom. There you have it. A button. Amazing. And then I'd bevel it a bit just so you get a bit of an idea of its real shape. And if you can't quite get the thing you're going for with your bevels, you can just type in 0.087 if you want to be very specific. And of course, we gotta soften that edge. Alright, so that's pretty much everything. This is obviously on the other side. I don't put in these grooves, there's no reason to. You saw how normal maps work, and in Substance Painter, which is the program we'll be using and we'll be learning in the next few weeks, after a few weeks, you can paint in normal detail. So I can paint in this gap. I don't need to put it in the model. So how do we do the toaster thingies, right? That's a bit weird. So it's a bit tricky because as I've shown you before, if you select multiple if you select multiple faces that are touching and you try to extrude, they extrude all together. So what I had to do is I extruded opposite faces and change my pivot point to component, right? So I did two each first, and then I had to somehow match them so they're all the same. Let me just delete my history so nothing crashes. So what I did was I selected all their bottom segments, and as you can see, this is completely flat, so I don't need to worry about it becoming uneven. And I used the scaling function, which I've shown you guys today several times, to make them all straight and in line, parallel. Did for the top as well. And then all I needed to do was make them the same width. So what I did was I just matched them to their bottom vertices, which should be the same as each other, like this. And because they're not fused together, like I can grab this and move it and you see there's still information there. I can now grab each face, go to scale mode, change my scale to component, and this time it's going to select them individually because they're not connected. They look like they are because they're right on top of each other, but they're not. So the component mode will allow me to treat each one as a separate component rather than as one big selection, and allows me to scale them individually with component mode. For those that don't remember, whichever manipulator you have selected, if you hold that manipulator's button down, so I'm holding R for scale, and you hold down your left mouse button, you can switch between your pivot point types. So by default it's in world, so it's based on the whole world. You have object, which is based on the object's rotation, which is currently matching the world. And you have component, which is based on your selection groups. So because they're not touching, they're each a separate group. And having them selected like this, I just extrude them down, and then I select the loop, the poly loop for each one. And you can tell that it's selected the other side as well. And then we can do a bevel. Boom. And it's given us this hideous nonsense here, which I fixed by essentially connecting them all to each other instead of having them connect to something else. So this one I kept, these ones, but the top ones I connect to each other because it's just less ugly. Right, and then we can grab our trusty target weld tool and pull these ones to where they're supposed to be, like that. What did we do with these ones? We got rid of them, I think. We don't need them anymore. Control delete. Yeah, and I did that for the rest, I believe. I won't do it for the backs because I don't want to you get the picture, right? I'll just delete. Essentially did that for all of them. I won't do it for the rest. You get the idea. So this just fixed it a little bit because afterwards I could just double click. Oh, I need to, of course, connect them at the bottom as well to get rid of this huge shape that has no squares whatsoever. So there was a lot of cleanup I had to do as well. But this fixes the topology just a little bit. So when I double click any of these edges, I can select the rest. And it has slightly better flow because at the back, and all of this I had to clean up as well. And you know, the more complex your object gets, the harder it is to keep good flow and good topology. I've tried to here, like you noticed I was trying to make sure things go the way around so that the object essentially flows better. It's easier to UV, it's easier to select edges. I can double click and select whole loops almost because I forgot to fix this. Oh my god, see? Little things like this. So there's a few things to fix. And then when I go and make this into a low poly, I can just go in here and I can be like, okay, well, I don't want this. Actually, I do want this because it's important detail, but I don't want this middle thing. Don't want this other middle thing. I'll go in here, and if I was really, really picky, I'd like try and make this lower, but there's no reason to. It's not a complicated asset. It's only like 500 tries, which is almost nothing. Okay, yeah, I think that's the main parts. Last thing I'll say about this before moving on to character stuff is if you want to check it whether your mesh has any errors, you can select it. You can go to mesh. Let me hide this thing. You can go to mesh and you can go to clean up, but don't click it. Click the option box and change it from clean up matching polygons to select matching polygons. And then make sure that on your choices you have faces with more than 4 sides, n-gons essentially. And click apply. And it's going to select all the faces which essentially have more than 4 sides and that you need to fix. And you can see them. And you can also see up here in your poly count, which you can see by going to Windows, where was it? Display, sorry, not Windows. Display, heads up display, poly count, right? So you can see in your poly count that it selected stuff. If it selected nothing, all of this would be 0. So there's like 21 faces that need to be fixed. If you have a really complex model and you can't even see them on the mesh, but you can see that they're selected, just click the isolation tool and it's going to show you just them so you can try fixing them, right? Now, the reason you do this instead of, so selecting it, mesh, clean up, the reason you do it, select matching polygons and face with more than 4 sides, is because you have to clean it up yourself. Not just because I want to make you do it, or because it's like, oh, don't be lazy. No, it's because it just, if you do it automatic and you just clean up matching polygons, it's gonna mess it up. Like if I click apply, this is the result. And this is just some, like, I don't know, tell me an artist's name that does abstract art. It's abstract, it's crazy, it doesn't work. It's gonna take you 7 million years to UV because you have to select every single edge by itself. Yeah, this is just a toaster. Imagine you're doing a character that's 50,000 tries and you have to select every single face because your topology is garbage. This is bad topology. If you were curious how really, really bad topology looks like, this is it. It's just a mess, right? And I just did it by hand. I went through one by one, and the result I had was, you know, comparatively a very clean low poly toaster and a slightly less clean high poly toaster that you can't even tell the difference. I think I already deleted a lot of the details to show you an example, but yeah. And I think that's mainly it. Like it feels odd. It feels like I end these at a very odd way. These demonstrations. It's like, oh, well, it just finishes now. But it's because that's pretty much it. Like it's literally just me using the tools that you learned in week 1 and 2. It's literally just learning more ways to use them and be like, oh, I can put an edge around here. I can extrude face by face. I can pull the front out to make it slightly more curved. I can put an insert edge loop in between and pull it down, and then harden the other edges to make it look like a groove, right? It's little things like that. Yeah, okay, all right, that's enough of Toaster McToaster. I think there's one more thing I want to show you with characters before we move on to feedback. And that's like a lot of the stuff, pretty much everything I wanted to cover today. Baking, introduction, optimization, which I've already shared a video with you about, and some modeling stuff. So the last thing is some character stuff. How do you pivot snap again? You hold V on your keyboard. You hold the letter V. Nice toast. You can pivot around the object by selecting it and pressing F. What is? Why are sides with more than 4 sides and faces with more than 4 sides an issue? Is making a pentagon illegal? Right. So the reason faces with more than 4 sides are an issue is because one, it messes up your topology. So the more, essentially, it makes, let me just get rid of this stuff. It makes it harder to work because you can't select your poly loops. You can't even select edge loops properly. I'm double clicking this middle one and nothing's happening. If you want to bevel this, it's going to give you errors. It can't be calculated. If you want to essentially do any kind of function on a face that's an n-gon, it's going to give you an error because the way computers calculate geometry and graphics, the maths is based on it's based on triangles, it's based on trigonometry, it's based on that stuff. And even these four-sided faces that you see are simulated from triangles. That's why in some video game engines like Unity, when you import an asset with quads, it automatically changes it back into triangles, because even these squares are essentially a preview to help us model. They're a preview to help us select edge loops and make it a little bit easier. They're as far as you can go above triangles, and triangles aren't supposed to be even used in certain situations because they make certain things complicated. For us, it's okay for now. But yeah, quads and tris are the only thing that the system can calculate. Anything above that just makes your life harder, and the system can't calculate it. Someone asked yesterday about reports. So I wrote in the general chat, if you just check the overall general chat for level 4, you'll see the answer there. So if anyone has any questions about the reports, read that first and you'll get some more information on how they work. After that, someone asked a question that I didn't answer, which was, is the 750 words 10% the maximum or the minimum? It's both. You can go 10% above or below 750. You can't go anywhere beyond the 10%. So 10% is 75, 750 is 75. So whatever 750 plus 75 is, that's your maximum. And you shouldn't go above that. You can go above it, but you will be penalized some marks for not being able to stay within the boundaries based on that thing. So that's some boring marking stuff I wanted to get out of the way in case anyone was curious. Okay. I think we're good. I think we're good to keep going. I told you, today is just packed. It's just one after the other, big stuff. So I'm gonna very cheekily steal something from the internet. Character A pose concept art. Let's find something very quick and dodgy. I need something like very basic and specific. This is hard. Okay. Yeah. All right. This is the one that a lecturer of mine used like 5 years ago when they were showing us what I'm about to show you. So I'm gonna use the same one. Can't believe it came up that quickly. Let me just check. Okay, so file. I'm gonna add an image plane. So what am I showing you now? Before we go into feedback, just to touch on character stuff and Weaver-Cow stuff, because we've been doing mainly general theory today. One of the ways you can model characters is essentially by using cylinders, using tubes, and you make the character's body at least out of tubes. And I'm going to show you what that means in a moment. This is something that I was shown in my first year back when, we learned they gave us things at a slower pace. As they saw that we can handle more, they started giving the first years and years after that more and more. And we're still going up. So you guys are learning more stuff early on than the people from last year because you can handle it. And I know you can handle it. When people stop being able to handle it, that's when we'll be like, okay, maybe we should slow down a bit. Can I save this image, please? on the week 5 lecture. Okay, fine. Week 5 lecture. Bam. Excellent. Alright, so we got this lady, this woman here, and I'm going to show you one way of modeling which I don't like to use. I don't like using Maya for characters, but sometimes you might need to use this technique, essentially. And it might be useful to you for Weather cows when you start going into certain things to do with the body, etc. So I've put my references here. I've put it so that from the front, I believe, from the side I should see the side, and from the front I should see the front. Right in the middle. Okay, and essentially what we were shown all those years ago was that we can start with a cylinder, and we can try and match the cylinder to the body of the person, or the figure, or whatever it is we're making. And it's kind of like the stencil modeling I've shown you guys previously. But essentially, you build up the figure out of cylinders, and I should have started with a lower resolution cylinder. You can haven't done this in a while, this cylinder modeling stuff. Maybe even all the way down to the bottom of the torso, and then you could put in. And yeah, this is literally it. This is essentially what I wanted to show you guys, just because it's something that used to be done quite a lot. Obviously more elaborate than the extent I'm taking it now. But whilst you're making certain parts for your characters, since we are working in Maya, you might try using cylinders to block out different forms, etc. So you can tell I'm trying to like kind of match the body somewhat. You can then switch to the side, which is facing the wrong way. So let's go orthographic right. Nope. Orthographic left. Thank you. And then you can go here. Let's make it transparent. This is like a terrible concept. Apologies to whoever made the concept, of course. It's not like... never mind. I shouldn't diss people's work. I apologize. It's very rude. I just don't like it personally. Excuse me. Excuse me for being rude. Yeah, this is pretty much it. I don't like personally using this method because it's very fiddly. I then have to come in and essentially mess with a lot of stuff. I have to mess with how the legs are going to connect to the body, how the arms are going to connect to the body. I will have to make the arms separately and then connect them to the body. There's a bunch of stuff like this. I'll have to come in and you have to solve a lot of problems, right? And me being a ZBrush user, I prefer to solve those problems after I finished my sculpt, right? But for low resolution models, it's actually a lot easier than, in some scenarios, it's a lot easier than sculpting it. Because when you're sculpting, you're trying to figure out so much information that you might not even need. Whereas when you're creating a low resolution model, it's all about these base shapes, these most important shapes, right? And I don't need to be trying to figure out a million things about anatomy to do that. All I need to do is match the shape which someone has already drawn for me. And in your case, that someone is going to be you, because you're making your own concepts for these things. So when you're making your concepts, it might be useful to think about how you're going to model them. And if this is a way you want to try, you might want to do some tests using this method to see how you get on. If this is something you want to try, might be a viable way to make concepts that match this way of working. And you can see what I'm doing. I'm literally just matching polygons to the figure that someone has already drawn. And for you guys specifically, for making these concept characters, this could be a viable method, regardless of whether I like using it or not for characters. The kind of characters I make aren't the kind of characters that you guys are going to be making for Weather cows. The ones you're making for Weather cows are much more stylized. They're much more how do you say it? I've clicked something and I can't see my cursor, and it's really annoying. Oh, that's really annoying. Why can't I see my cursor? Oh, yeah. So it's useful for you guys. Is the base idea there. And for those of you that make they like cartoony characters, they like stylized stuff like this, you might even use something like this in the future. This kind of technique for the kind of concepts that you make. Who knows? Alrighty. And you know, apart from certain things, the shape isn't matching terribly, is it? You have a very easy reference to work with. There are certain issues we'll have to solve, but we can solve those after kind of getting the base forms down. And you don't have to spend a million years in ZBrush trying to figure out what those forms are, because someone's already gave them to you and you're essentially tracing them. So you have like a starting part for the body. What I would do after that is essentially I would make another cube and do the exact same thing. I'm not going to do it now, don't worry. But do the exact same thing I just showed you for the arms. I'll literally put them all the way to the top. Maybe not to the top because I'm going to have to curve that for the shoulder after, but to the top, and then just go pop, 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 pop. And then start like doing this stuff one by one. And I believe there's... And that's pretty much it. After I make the arm, this part I would have to curve. And you're not going to do this because you're not making a human like this. And you won't have to do these fingers and all these specific things which I would have to cover otherwise. Yeah, but then you could move it into position and figure out how you're gonna mesh those together. And I think for you guys it's gonna be more straightforward than this stuff. And also this has way too much detail. I would get rid of a lot of these details around the model. But it's about essentially taking a few of these faces, which currently are in terrible state, terrible topology. This is not workable. I would try and make this be more even. I would put in more stuff, etc. But you would essentially take the faces that you're working with and try and make them into a sphere that's going to connect to the cylinder that you're essentially creating. That's going to connect to the arm. So essentially matching the arm shape at the top, and then you could grab this stuff however you, not like this that I'm going to do now, but the concept is that you match the two things that you're connecting, right? And then you carry on modeling in it. Yeah, so this might be something you could use, depending on what kind of concepts you have. And just as a quick show, so this is a high resolution, well, kind of high resolution model. It can be low. It needs to be lowered down. It's like 2000. It's a tiny knife, but essentially this was modeled the same way. I had my stencil and I just started working on it. From that, the cylindrical parts are obviously made from cylindrical stuff. The blade was made slightly differently using a square and getting some different details out of that. And these things look complicated, right? But literally, it's just a cube with... I'll just do it quickly. And then you grab the end. And you turn your soft selection on. If you guys remember soft selection, you press B, and it goes into soft selection, and you hold B and middle mouse button, stretches out, right? And then you can just whomp, rotate, and you got something looking cool. So the reason I show you this fancy knife is because if you're making specific bits for your character, so you're making certain bits of its costume, maybe it's holding something, if it's something more complex, you could use something like this where you essentially draw a reference for yourself in this perspective, or find one if you're just going off existing stuff. And I didn't draw this, I found this. And then make the asset on top of it. And notice it's made from separate pieces. It's not all the same piece. This was two separate pieces as well before I combined it. And it's still in high poly mode. You can tell I've put like lots of details in here that I'm going to get rid of for the low poly. And I was actually going to use this as an example to show you how to reduce high poly details, but I think I covered that quite a lot already. Yeah, so that's a few things you can use for your weather cows. There's specific other things, that's a weather cow pun for you. There's specific other things that we can do for the weather cow stuff. For the moment, you know, some of you are still figuring out designs, getting started with modeling. We'll cover more stylized modeling techniques, specifically that you can use in Maya in future. Next week, we were supposed to do baking, which I did this week. But I think next week I'll try and put together a more easy to reference presentation. So instead of having to watch through my 45-minute talk on baking, that was rather, depending on how new to this stuff you are, it might be difficult to follow. Hopefully I'll put something together that is essentially a document that you can reference and look at for like 3 minutes and you'll know what you're doing. So next week we might be covering just a little quicker refresher on baking using the document, which will only be like 15 minutes. And then we'll start going into some other stuff. And the week after that, we'll probably be doing texturing. We'll probably be doing Substance Painter and start getting into texturing. Next week is our review, actually. So I'll be putting you in groups and we'll be getting together and we'll be doing group reviews. And the only difference is there's more of us in a group instead of one-to-ones. And you'll be able to give each other feedback as well. So don't feel stressed out that you're sharing your work with others or that you're going to see other people's work, or you might think they're further ahead or you might think they're not further ahead. It's about feedback. It's about practicing that group discussion, which when you work with other artists in a studio is going to be very valuable. So next week, yeah, I think we'll cover baking for like 15 minutes just to show you guys what the document is and how you can use it. It might even go into texturing a little bit. And then we'll get into our group sessions, group feedback sessions, and the week after that we'll cover texturing. I think that covers it pretty well, what we're going to do ahead. Yeah, so as always, if someone has any issues, they can come back, they can send me a message, do modeling or anything else, and we can go do, I can give you some specific modeling help. Okay, let's see what's going on. Does our Weberco have to be fully 3D from all angles, or will it be kind of flat since the app, the cows are made more 2D, I think? Yes. So the app is 2D entirely. The app is from vector graphics. We're creating them in fully 3D, so completely 3D. So imagine that the app was going to be fully 3D. That's what we're doing with the Weber cows. They will have to be fully 3D from all angles. You can use some 2D textures for some stuff. So like if you're putting like, I don't know, that's more advanced stuff. I don't want to go over it, but essentially imagine you're making a tree. You would make the leaves from flat planes, single-sided faces. So if you have anything on that on your character, there's a way to do it, but we'll cover that when we get to it. But yes, fully 3D. Are we allowed to look at the old student work that they did on the Weber cows? I'm still not able to get to it. Partially because I forgot that I was supposed to look for it, to be completely honest. But yeah, I need to figure out where I can get that from, and I don't even know whether I'm allowed access or whether it's free to share between staff. I'm not sure. There might be some kind of GDPR kind of legal stuff to do with student privacy. I really don't know. I do know that we can use it for promotional purposes though. So I'll take a look. I'll send Matt, I'll write a note to send Matt a message because I want to see it too. Okay. All right. I think we're all right. I think we're good to go into feedback sessions.